Welcome to yet another episode of Netmother Tech Academy. Today we're going to do something fun and interesting. We are going to write a Python program to solve a Sudoku puzzle, and we are going to use a backtracking approach for this. So let's start by creating a Sudoku puzzle. So what I'm going to do now is I'm going to make a text file and input a Sudoku puzzle like this. So that way we can change the values and test it. So I'm going to start by creating a class. And as always, when we create a class, let's create a init function for it. And we are going to pass the file name into it. So we're going to make a variable called board, which will hold the whole board, the Sudoku board. So let's start by opening the file. So f is equal to open file. So file is the name of the file. In this case, it is board.txt. So what we are going to do now is we are going to read the file and fill our self.board. So for each line in F, what we are going to do is we are going to make an empty list which we want to put into the board, because our board is going to be a two-dimensional list like a matrix. And then for each number in the line, we are going to check to make sure that there are no spaces before or after. We are only interested in the number, and if we actually have a value, we are going to put it into our list L, and we want to put it as a number, not as a string. So let's do an int on it. And finally, when one line is over, we are going to put that list into our board. So self.board.append L. So that should fill our board. Let's see if it works by doing a simple print statement, print self.board. So let's go ahead and create an object s sudoku, and let's pass the file name board.txt. And let's run this and see if it works. That seems to be working. So we have read everything that's in the file, and that's our board for us to play with. But printing the board like this will not be helpful. So let's make a user-friendly print statement. We just need one parameter, which is the self. So what we are going to do is for each row in self, or we could just do range 9. So that is 0 to 8. And then for each column in range 9, we are going to print self dot board that particular row, column, and we're going to leave the end as a space, and we're going to make a new line only after every row. So let's try this method. Let's call the print board, and it looks like this. That's much better than the previous print. So this way we are able to see the whole board. Now let's go into the part where we have to solve the board. Let's say there are a few empty spots here. So what do we do then? So to solve the board, we are first going to start by writing helper functions. So first function I'm going to write is called isLegal. This is going to check if for this row and this column, if this value is a legal value. So Sudoku has a few conditions. So one is the number should be unique in the row, the number should be unique in the column, and the number should be unique in its own 3x3 matrix. So let's first do the row. So let's check all the items in the row. So all we have to do is check if self.board that particular row dot count of val, if it is greater than 0, that means we gotta return false. That particular value is already there in the row, so we cannot put it again. To check the whole column, we need to check all the rows. So for R in range 9, if self dot board of R and this particular column is equal to val, then we return false, meaning we found it in the column, so we cannot have it. We cannot have it one more time. So what we are doing now is we are checking the rows to make sure the new value that I have to put is unique. Then we are checking the column. Let's say this is an empty spot. If I try to put a 5 here, it should not be possible because there is another 5 already here. If I try to put an 8 here, it should not be possible because in that column there is an 8. The last thing we have to do is we have to check the 3 cross 3 matrix that it belongs to. So we need to know which matrix each cell belongs to. So we can find that by the starting row of the matrix. We can find it by taking the current row that we are at, divided by 3 and doing a times of 3. This will tell us which is the starting row. Say, let's go with the same flow for the column as well, times 3. So what we are doing here is, let's say we are talking about this row. So this is row 8 and column 6. So if you think about row 8, 8 mod 3, sorry, 8 divided by 3 will give 2. 2 times 3 will give 6, and 6 will give us the beginning of our cell. So 0, 1, 2, 3, 4, 5, 6. Yes. And then if 6 is our column, so 6 divided by 3 is 2, just the integer part, times 3 will give 6. Let's test this with another cell like this one, 2 cross 2. So this is the 1 cross 1, because row and column starts at 0. When I pass 1 cross 1, the particular 3 by 3 matrix that it belongs to starts at this point, which is 0, 0. So I should get 0, 0. So 1 times 3 is 0, 0 times 3 is 0. 1 divided by 3 is 0, 0 times 3 is 0. Yes, it works. So that way we are able to find the 3 cross 3 matrix that individual cell belongs to and where it starts. Now that I have that matrix, I can now do a loop of for R in range 3. Now I only need to check the 3 by 3. So for C in range 3, if self dot board this S row S call, we need to increase the column every time. So I'm going to put it into a temporary S call as well and use the temporary variable here. You would know why that's needed. If it's equal to var, n equal to return false. And we now need to go to the next column. So I can do tscall plus equal to 1. And for a row, every time the row starts, the tscall should come back to scall one more time. So that way we will be able to check the S3 by 3 matrix to make sure the value that we are putting here is unique in the 3 by 3 matrix. That's awesome. Now all that is done, all that is left is to check um, which cell to work with, or if there are any cells to work with at all. So we are gonna write a method called checkboard. What it's gonna do is it's gonna for row range 9 or C in range 9, it's gonna check if self dot board, that particular row, that particular column is equal to 0, meaning there is an empty cell. It's just gonna return that particular row and column. In case we did not find anything, then we are gonna return um, -1, comma -1, sorry. So when we return -1, -1, that means our board is actually done, meaning we have solved the whole puzzle. Okay, now that all our helper functions are out of the way, let's go ahead and actually make the function to solve the board. So backtracking, basically the algorithm is we are going to try to keep on putting numbers and keep on going forward until we hit a roadblock. Then we backtrack and try to change the previous number. So let's try and write the solve method. So all we have to do is first check. First we are going to find the row and column that we want to work with. Okay, so we are going to do R and C, and we are going to do it by calling the checkboard function. Now, if R is equal to -1 and C is also equal to -1, that means we have solved the puzzle. So I'm just going to return true. Else we know we are working with an empty cell. So if it is an empty cell, the possible values that can go into it are 1 to 9. So let's write a range from 1 to 10. So first thing we are going to do is we're going to check if it is a legal move. So here it's not legal, it's not legal, it's not legal, but if we reach till the end, then we have to return true, so it becomes legal. So if I can put the value val in the current R and C row and column. So we are going to call self is legal R C val. If I can actually put the value, what am I going to do? I'm going to actually put the value. So self dot board R C is equal to val. Once I put the value, I will have to try and solve to make sure the whole board is done. So I need to call the solve method again. But this solve method is going to return something for me. And if that is true, that means I have solved the puzzle. But in case I have reached a point where this did not solve the puzzle for me, and the value that I tried to put there, it was legal, but it did not lead to a legal final solution, then I need to backtrack and try a different value. So I'm going to mark the cell as empty one more time, and we are going to continue in this loop and try a different value. And if we have completed the whole loop and even then we are not able to solve the puzzle, then probably there is no solution, or the solution that we tried to feed is erroneous. So we can return false. So let's see if this works. So to solve this puzzle, all that has to be done is a 6 has to be put here. So let's go ahead and try to call the function. So if s dot solve, then we're gonna print success, and we are going to else print not solvable. And at this point, let's also call the print board function to make sure we can see the final solution. So solved error is in line number 55, SOLVE. Let's try that one more time. Okay, so it says success and the value has been filled here, which is good. So now let's try to make it a little harder. Let's remove this whole row and fill it all with zeros. And let's try this one more time. And still success. We were able to solve the whole row. That's awesome. And now let's try and see how this is actually working. So what I'm gonna do is I'm going to import OS so I can clear the board, the console window every time I print. So before I print the board, I'm gonna do os dot system clear, and every time I come into this method, I'm gonna put an input statement. So it'll stop for me. And I'm also gonna call the print board function here. So now let's see what happens. So this is the original board where everything is already solved, so nothing happens. We need to put some zeros here. Let's do Control Z. Okay, so this is the original board. We have all zeros here, and now we have filled the value 4 here, and we are continuing. That's awesome. We did not backtrack even once here because the solution was too simple. And now let's try to make it even more harder. So I'm gonna copy this and paste it in a few more rows. And I'm also gonna make some columns as zeros and see if we get the same solution. So let's save the solution here. And now let's make some more columns 0 and make a even harder problem. And let's try this. So this is the first 0. So let's see what value gets there. And 1 goes there. Actually 7 should be the value, but now our algorithm is trying with 1. So let's see how far it goes. And now you can see it's already trying to backtrack because none of the values are working out. So as it tries to go forward, it is also coming back. And now let's hope it solves it faster. And now I'm holding the enter key, so it goes really fast. And these many iterations are being tried at this point. Okay, but still we can see the second column, the value is 1, and it's taking quite a bit. What we are trying to see is if the backtracking is working fine, and we come back all the way to make sure we find the right solution. Looks like this was a really hard one to crack, and it's taking a lot longer than expected. I'm gonna try and keep it going for a little bit more longer. If not, we can comment out the input statement and we can try and run this to see if it finds the solution. Okay, so it is indeed taking longer. So one way is to just comment these things and try and run this. Oh yeah, it actually solved it. And now we can see that we got the same solution that was possible. It was much faster after commenting out the input statement. Nice. So that's all for today, friends. We saw how to solve the Sudoku puzzle with backtracking. Hope you are able to learn something new today. I'll meet you all in the next video. Bye, world.